Have you ever watched a construction crane slowly lift a massive concrete slab, cables pulled taut, the boom bending under the strain, and wondered, why doesn't that hook just snap? How can a piece of metal roughly the size of your fist hold a load heavier than an entire bus? Every day, this silent spectacle plays out on construction sites around the world, and almost no one stops to ask how it actually works. But behind the crane hook lies a story of materials science, physics, and engineering decisions that quite literally shape the skylines of our cities. Today, we're going to find out why the crane hook is one of the most underappreciated masterpieces of engineering, how it's built, what it's made of, and why it's deliberately designed to bend, not break. By the end of this video, you'll never look at a construction site the same way again. Cranes have existed for thousands of years. Ancient Greeks used them to build temples. Romans lifted multi-ton columns with their help. But the hooks of that era were primitive. Forged iron, simple shapes, no strength calculations whatsoever. Everything changed during the Industrial Revolution, when construction leapt into an entirely different scale. Loads grew heavier, heights got greater. The consequences of failure became catastrophic. Engineers realized they couldn't simply make the hook stronger. They needed to understand exactly how it fails and design it so that failure would be predictable and visible well in advance. This is where it gets fascinating. A crane hook experiences not one type of stress, but several simultaneously: tension, bending, and torsion. Think of these as three different forces, all trying to tear the metal apart in different directions at the same time. Modern crane hooks are made from high-strength alloy steel, a blend containing chromium, molybdenum, and other elements that make the metal not just hard, but tough. This is a critical distinction. Hard metal is brittle. It holds the load, holds it, and then suddenly fails without warning. Tough metal begins to slowly deform long before it ruptures. It bends, and you can see it happening. That visible deformation is the built-in warning system. A hook that has bent is not a broken hook. It's a hook that did its job. It gave people time to step away. Look closely at the shape of a crane hook. It is never straight. It's a curved, asymmetric, carefully calculated profile. And every millimeter of that curvature is the result of deliberate engineering. The curved shape distributes load evenly across the entire cross-section of metal. If the hook were straight, stress would concentrate at a single point, and that's exactly where a fracture would begin. The curved geometry literally spreads the force out. This is the same principle behind an arched bridge or an eggshell. Curvature is strength. Modern hooks are also fitted with safety latches, small spring-loaded tabs at the throat of the hook. These prevent a sling or a cable from accidentally slipping free, even if the load suddenly shifts direction. Even a perfectly engineered hook doesn't last forever. Every crane hook undergoes regular technical inspections. Engineers measure the throat opening, the gap between the tip and the shank of the hook. If this measurement has grown more than 10% compared to its original specification, the hook must be taken out of service, not next week, immediately. Why 10%? Because that level of stretching marks the point where irreversible changes begin in the metal's crystalline structure, invisible from the outside but critically dangerous. The hook may look perfectly normal and yet be on the verge of catastrophic failure. This is called metal fatigue, and it kills without warning if you don't know where to look. The next time you drive past a construction site and watch a crane lifting a load into the sky, remember, hanging on that single hook is an entire body of human knowledge. The physics of bending, the metallurgy of toughness, the engineering of predictable failure, and a quiet philosophy that's rarely stated out loud. The best safety mechanism is the one that warns you it's about to fail. The most overlooked details of our world are often the most carefully considered. You just have to know where to look. If this video gave you something to think about, hit like and share it with someone who loves finding meaning in ordinary things. Subscribe for more stories about how the world around us actually works, one surprising detail at a time.